Hello, I am a prisoner, a member of High Performance Cloud Computing Lab. So in this video, I will guide you to the tutorial that I have sent you as a part of the study. So in this tutorial, it will introduce you the concept of serverless, which have a two paradigm. The first one is function as a service, which is the paradigm that used by a lot of commercial cloud right now. And we also have the object as a service, which is the paradigm that developed by us at PCC Lab. So in the function as a service, you can imagine that uh, basically cloud give you the abstraction that you can just write the code as the stateless function, and this function can be triggered by the event. So behind the scene, when it triggered by event, the cloud going to provision the resource. Resource mean computer which have like CPU and memory and then the storage. It just run it somewhere that you maybe know or maybe never know. And it just handle your code like that. So in the FaaS, you basically just write as the function. And in this example, you can see that it basically really simple function. And in this example, it actually wrong because it try to access to the local data, local parameter actually. And the problem is, since when there is a event trigger the function, so cloud going to create the function runtime somewhere, and when it's no need to use this function anymore, it just disavow. And when it disavow, it basically remove this temporary parameter in here. So you can imagine that if you want to keep something persistent, this one is not what you want. And it's not reliable as well. So you can imagine that if you have like 10 million user asset at the same time, so they're going to spawn a lot of function instant. And the thing is, in instant there is like only one local parameter. So basically, they just update to the local parameter. It you don't get any useful result because this parameter only represent to the function that your code is run on the local, but not at the global. So this one it doesn't work in the way that you want it to be. So to solve the issue in the industry right now, so they need to connect it to the external storage. So one of the popular storage right now is S3. It is the stand for simple storage system. So basically, it's just a simple that okay, you have a data, you just write somewhere with the key, and then you can read it again with the same key. So in this case, you just need to updating it. So you just if you want to have a same thing before, so basically you need to encode the counter into in this case it's just a string. But if you have a more complex parameter, so you need to somehow encode it in maybe JSON or something and write to the S3 storage, and then you need to read it again when you need it. So like in here, you can see that we get the data from the S3 first and do some incremental to it and write it back. So you can say that it definitely doesn't uh, some something special here. And the next problem that we want to talk about is the function to function call. So you can see that um, since the cloud is managed the function lifetime, so basically you cannot guarantee that okay, when you want to call the function, it's going to be there. Uh, so you cannot just call the function directly. So you need to use the API that provided by cloud, so that we call as a direct invocation. Or sometimes you can connect it to the some kind of like queuing system. So and we don't want to go to that detail yet, but the key point I want to say is that okay, if you want to call another function, you need to use some low-level API to uh, call the function directly, or maybe using some message queue to call it. So And alternatively, instead of using the function as service, we also have the object as service, which developed by us to elevate the problem that we have in the FaaS. The core idea is we try to improve the productivity by introducing a new concept that is the object instead of uh, concept of stateless function. So in the object, you can think of in the OOP that, okay, when you write a class that's going to initiate as an object later, but when you write the class, you're gonna write about the state of that class, and then you just write a method that do some interaction to the state. So the good thing about the object is it's not just about the function anymore. It's just about the function and data. Function can call as a method. So and there is the affinity between the method and the state as well. So which can be helpful for the system to do some optimization, but we don't want to touch that concept. So to use OAS, you can see that you just use the annotation. And in the Python, we call as a decorator. In Java, we call as an annotation. So sometimes I may use a two word interchangeably because sometimes I cannot, I get used to call it as an annotation. So in here, we have some annotation that you can use to make sure that the system know that, okay, you're gonna use this class as the OS class, and then you're gonna have this function that as a method of this class. So, but other than the annotation, you will see that it's just classical OOP style of writing something. So you're gonna have this class as a service, and then you're gonna have the state that going to be persistent automatically. You can create the object using the create API. You can, you may need to assign the object ID, but that is a not really important detail. And then you can just call to the method with some argument, and it's going to increase to the count parameter. And if you do it 2 times, it's going to persistent. So in this code block here, you can see that it basically run on the Jupyter runtime, but in the cloud, this code going to get deployed. So basically in here, it's just a conceptual uh, elaboration of how OS should work. But when we need to use it in the production, this code going to run on the cloud, and this code going to run on the external system that want to interact with the object that deployed by OAS. So basically, we can just create object, and when you run the incremental, it sends something over the network to the cloud and let the object on the cloud running it. So the good thing about that is object is can be accessed anywhere. So you have the identity of the object, which is ID, and yeah, and the life cycle of the object is made by cloud. So you basically as a developer, we don't need to uh, think about the infrastructure. We just when I say about infrastructure, it includes a message queue and the storage. All you need to do is basically focus on the application logic, which is sometimes we call as a business logic. So, and we also have more uh, example that if you have an object that two objects may need to interact with each other. So in this case, we have the session counter, and then we have another object that called as user manager. So in the user manager, we have the state that is the reference to the another object, and you can just call this object directly here. So behind the scene, it's going to initiate some kind of network call to another object that runs somewhere on the cloud. So for reminding, so like when we talk about this, everything is serverless. So when we talk about the serverless, that basically you don't need to aware, okay, how it's going to run. So it just runs somehow. That is the promise that given by cloud developer. So as a developer, you don't need to worry about it. You just like connect the two objects together and expect it to behave like that. So we also have a more realistic, a bit more realistic example. We call it as a real-time parking lot occupancy counter and reservation system. So basically, you can imagine that some kind of IoT uh, use case that, okay, you have a parking lot and you want to put some smart net into it. So you have some light signal with some sensor that, okay, if you have some car parking on the certain spot, what happen is it basically uh, activates some signal light. So, and that is too simple, right? So basically we want to sync the state on the parking spot to the central system, and the user can use the app to reserve any spot. So when the any spot being reserved, the system need to send the signal to the signal light on the spot to turn on the light to say that, okay, this light is being reserved and no other car should use this location. So with that, you can see that there is two direction of the communication between device and the cloud. So because the thing is we don't want them to aware of each other, so we need to add some level of abstraction here that is we call as an MQTT broker. So basically it's somewhat some kind of message queue. So you just send the message as a high level, which is topic and the payload. So and the broker is going to route your message to the destination uh, with your the topic. So it just adds some abstraction that because as you know that okay, if you want to send the data from one location from in the network to another location, you need to have IP address of the destination. But that just add the complexity to the system. So we want to have some level of abstraction. So that is a community broker. And again, if we want to send some data back from the function to the IoT device, in this case, it's just signal line. You just send it to the MQTT broker, and the device that run on its parking spot going to subscribe to the MQTT broker and get the message based on the topic. So for the FaaS system, you can decide. You can see that it basically you need to handle the MQTT broker directly. So you need to connect to them, maintain some connection, and interact with it. And then you also need to have the database to keep the state as well. So alternatively, if you use the OaaS, so as I already mentioned, so now you use on the serverlet that should be truly serverlet. So you should not need to worry about the infrastructure anymore. So everything it should be abstract based on the class and object. So in this case, we're going to have a parking lot which represent uh, array of the parking spot. So in the parking spot, this object, we have this object that represents the parking spot, and this should connect to the device. So basically, anytime that it see that, okay, there is a car parking there, it should update the status to the parking spot. And then if the function or the method of the parking spot being called to reserve to turn on the light, so it should send the data to the signal light to turn it on. So first of all, you can see that okay, the object has some the state correlate to it. So basically, if you want to send the data to specific object, you can do it without using the MQTT because there is the affinity between the object and the real device. So when you send to the object, object should be able to run it somewhere. Uh, in this case, it should be run on the cloud and then represent it to the local device. And the next is we have a parking lot, which is just a logic that we try to do the reservation spot and get some metric. Let's say it could be the already counting. And then if the admin want to add new spot and remove the spot, they can do it here as well. So we have a code example here. You don't need to go through every single line of code, but just get some idea that how it should work. And that should be everything. Thank you for your attention.